Now that we've reviewed the right angle triangles, we're going to start to take a look at acute angled and obtuse angled triangles. So triangles that don't fit into that nice, easy right angle ratio. So we saw that we could use the SOHCAHTOA, like we did in grade 10, in order to solve the right angle ones. In the next section, we're going to determine the side of an acute angle triangle by either splitting it into two right angle triangles and using the SOHCAHTOA, or by using the sine law, which is going to be our first new method. So, triangle ABC has three acute angles. Using SOHCAHTOA to determine the length of BC, work to 3 decimal places and answer to 2 decimal places. So, the first thing that we're going to do is they've already split up using this new point of D to turn it into 2 right angle triangles. With this information, knowing what this angle is and what this hypotenuse side length is, I can solve for what the opposite side length is, just of this right triangle here. So I'm going to say, well, if sine 20 is equal to the length of B going to D divided by the hypotenuse, 12.5, then 12.5 times sine 20 is going to equal the length of B to D, which means that 4.275, if I go to 3 decimal places, is going to be my BD. At the same rate, I can figure out what the length of A to D is, so I have enough information to solve this right triangle, which currently I don't know what any of these side lengths are. By saying that this is going to be my adjacent side length in this case. So I can say, to solve this, that cos of 20, because I'm solving for the adjacent, is going to equal AD divided by the hypotenuse, 12.5 or 12.50. So 12.5 times cos of 20 is going to equal AD, which means that 11.746 is going to equal AD. And now that I know that this length is 11.746, now for this triangle, I have the adjacent, and I can solve for what the opposite is, or that length of D to C, which means that I can say that tan of 55 degrees is going to equal the opposite, which I'm solving, DC, divided by the adjacent, which is going to be the 11.746. Which means that 11.746 multiplied by tan of 55 is going to equal DC, which is going to be the same as 16.775. Now, if I know that this is 16.775, and the other side is 4.275, I'm just going to combine them. BC is going to equal that 4.275 plus 16.775, which is going to give me, down to 2 decimal places, 21.05 centimeters. So we can just split this acute angle triangle into two right angle triangles, just making this vertical height that is perpendicular to the side B to C. All right. Often in trigonometry, it's convenient to use the following notation, where if I say that I label all of my angles, angle A, angle B, and angle C as my 3 points, then the opposite side lengths are going to be represented by the same letter in lowercase. So opposite of A is going to be lowercase a, opposite of B is going to be lowercase b, and opposite of C is going to be lowercase c. In sine law, our formula is if I know that the side length A divided by sine A, it's actually going to be equivalent to the side length B divided by sine of angle B, or side length C divided by sine of angle C. Another way we could write this is sine of angle A divided by A is the same as sine of angle B divided by B is equal to sine of angle C divided by C. So, the question is, where does this come from? Well, the diagrams show the same triangle, ABC, placed with a base of AB on the x-axis of this grid. In diagram 1, the origin is at A, and in diagram 2, the origin is going to be at B. So all they did is just reflected the exact same triangle. So if we're completing the work for this, in example 1, if sine A is equal to CD divided by AC, which is equal to CD divided by side length B, because we've labeled this as B, then that means that CD is going to be the same as side length B multiplied by sine of A. If B times sine A is equal to this, well, what happens if I take a look at the second case? I'm going to say that for sine B, from this angle here, sine B is going to equal the opposite, CD, divided by BC, which is our hypotenuse. And because BC is represented by A in this case, I can say that it's going to be the same as CD divided by side length A, which means CD is going to equal A multiplied by sine B. So if B divided by sine A, which will give me the length of CD, is equal to A times sine B, which is also the length of CD, then the two things have to be equivalent to each other. B times sine A has to be the same as A times sine B. If we divide both sides by sine A and sine B, then we get the first pattern. And because the pattern fits for two of the sides, it would work for any two sides that you pick.